Hello everyone, this is Abdul Jami. Today I will be talking about the depthwise separable convolution. So before going into the depthwise separable convolution, we have to first have the basic idea of the general convolution. Okay. So in general convolution, we should have a input feature like this. We should have a filters like this, and we will finally get a output feature like this. Okay. So what happens here is each of the filter is passed through this input features in a zigzag manner, and we finally get this output. And each of the channel comes from these filters, and the color actually represents which filter is responsible for creating which filter is responsible for creating which channel. Okay, so this is the general convolution. Now if you want to increase the number of channels of the input feature, you will have to increase the number of channels in the filters as well. Okay, so you will have to increase the size of the filters, and if you want to increase the size of the output, then you will have to increase the total number of filters. Okay, I mean, if you want to increase the number of channels of the output, you will have to increase the total number of filters. So if you want to double the feature, you will have to quadruple the total number of operations. So is there any way to reduce the cost? Well, there are many ways, but one way is depthwise separable convolution. So what we will do here, let's divide the input feature and the filters into two groups. Okay, so here you can see we have now 8 filters. Here we also had 8 filters. Now we have two groups in both input feature and also in the filters. Now this this group will be responsible to operate on this particular group of input channel, and this group will be responsible to operate in this particular group of the input features. And if the convolution is done on this channel, on this input feature by these filters, we will get this output feature map. Okay, you can see here our input feature size and the output feature size is similar as earlier, but you can see total number of filters is also same, but the filter size is reduced by half, right? So you can understand that our total operations are actually reduced. So if we divide them into more groups, then the cost will be reduced further. Okay, so here what we are doing is we are making total number of groups equal to the total number of channels, and now each of the channel will operate on each of the channel of on a particular channel at the same position of input group, and will be responsible to create a particular channel in the output feature map in that particular index, right? But there is the issue. The issue is, if we run this depthwise convolution in this feature map, this channel of output layer is actually built from this particular channel in the input feature map. Okay, so there is no information sharing from the other channels of the input image. But in general convolution, each of the channels in output feature map has actually some shared information from all the channels in the feature map. So that is actually an issue. So this is not actually fully replicating the general convolution. So there is a solution. The solution is to add a pointwise convolution after the depthwise convolution. Pointwise convolution is a one by one convolution. uh, it actually just used to recalibrate the feature map here. If we run this, you can see the channel size of the filter is same as the output uh, channels, or or the input channels. So this helps to uh, share all the channel information and put it in a channel. So finally actually we are getting something similar to the general convolution, but at a lower cost. Okay, so if you do some operations, you will finally see that the depthwise convolution is actually 9x faster than the general convolution. So yeah, that was all from me. Thanks a lot.